Hi class, welcome to exercise 1G. In this exercise, we're going to learn how to find the equation of a line. So the examples we're going to do and the questions related to the pre-learning are example 19, finding the gradient of a line joining 2 points. And the questions for you to do for this skill are questions 1 and 2 in the new book and questions 3 in the old book. Then the next skill we're going to learn is from example 20, finding the equation of a line given the y-intercept and a point. And your questions for this are questions 4 in the old book or question 3 in the new book. And then finally, we're going to move on to example 21, where we'll be learning how to find the equation of a line given any 2 points. And you can practice this skill with questions 5 in the old book or question 4 in the new book. The introduction for this video will be brief, just reminding you of what skills you need to have. As we normally do, I suggest you pause the video at the end of each example and have a go at the questions relating to that. Remember, it's good to know the concepts, but you're going to learn more about mathematics by doing. Okay, I'll see you in the introduction. Okay, welcome to the introduction. Some points that you'll need to remember. In the last lesson, we learned how to draw a graph from an equation. In this lesson, we're going to do the opposite. We're finding an equation from a graph or points on the graph. Things we know already from our last lesson, there is only one line between 2 points, and we can graph a linear relation by figuring out 2 points that satisfy that relation and then draw a straight line between them. We also know that the gradient is equal to rise over run, and rise is the change in y between 2 points. Also, rise could be positive or negative. And we know that run is the change in x between 2 points, and we typically express this as a positive number. Hopefully you already noticed this in the last lesson, but just to repeat it again, let's note that the ratio rise over run will be the same between any 2 points on the line. And in today's class, we're actually going to see that in action. And an important skill that you must have is that if you have a linear relation with 2 variables, you need to be confident that you can figure out the value of one of them when you know what the value of the other one is. Those of you with the new book can try the building understanding questions to test that you have the knowledge from our last lesson and the necessary skills that I've already mentioned. If you do have that book, pause the video and try them now. Otherwise, I'll see you all in the next section. In this section, we're going to learn how to find the gradient of a line that's joining 2 points. So this equation here is y equals mx plus c. And if we were to draw 2 points that sat on this line and call the first one point A, which has an x value of x1 and a y value of y1, and another point B, which has an x value of x2 and a y value of y2. Because we know that the gradient m is equal to rise over run, if we figure out the run and the rise, then we'll also know the gradient. To figure out the run, we only need to know the distance between x1 and x2. So run is equal to x2 minus x1, which I'll draw on the graph here. And to figure out rise, we only need to know the distance between y1 and y2. So rise is equal to y2 minus y1, which I'll draw on the graph here. This means that the gradient m is equal to rise over run, and as rise is equal to y2 minus y1, and run is equal to x2 minus x1, therefore rise over run equals y2 minus y1 divided by x2 minus x1. When a equal to x1 y1 and b equal to x2 y2 are 2 points on the line. So let's have a look at this in GeoGebra by following this link. Okay, here we are in GeoGebra. You're all welcome to use this link and have a play with this yourself. Hopefully it really illustrates this type of maths for you. So here we have 2 points. This one here has an x value of 3 and a y value of 1. And this point here has an x value of 5 and a y value of 5. So we can see that the rise is 4 between these 2 points, which is the same as saying 5 minus 1, and has a run of 2, which is also 5 minus 3. Now you can see that this line runs through x is 4 and y is 3. So if I was to move this point there, we would hope that the gradient stays the same, right? And before I move on to moving these points, if you look over here with the mouse, that there is the equation. If I move this point to there, so we've got a rise of 2 and a run of 1, and sure enough, we have the same gradient and exactly the same equation. And if I was to move this point down to x value of 2, y value of -1, we would still end up with the same equation. Y equals 2x minus 5. Also understand that GeoGebra is just a computer app, so it says plus minus, which hopefully you realize is minus. Alright, so we have a rise of 6 and a run of 3, so the gradient is 6 divided by 3 is still 2. And if I was to move this point elsewhere, say over here, you can see we now have a run of 3 and a rise of 3, so 3 divided by 3 is 1, and once again, the computer is weird. We don't have fractions here either, but hopefully you can see that that is 2 divided by 3 is 0.66 recurring, which they've said is 0.67. Also notice how x2 minus x1 is 5 minus 2, which is the x value here, 5 minus this x value here, and y2 is 5 minus 3. Okay, I'm going to go back to the OneNote, but as I said, you guys are welcome to use this anytime you want. Before we move on to the example, I would like to make one more point. It is important to note that we have y2 minus y1 divided by x2 minus x1, and that we notice that y2 and x2 are the same point, and y1, x1 is another point. When deciding which point is x2, y2, or x1, y1, the convention is to choose the bigger value of x to be x2. That way run will be a positive number. Let's put these concepts to work with a real problem in example 19. In this example, we're asked to determine the gradient of the line joining the pair of points -3, 8 and 5, 2. Okay, let's draw the axes and mark in x values -3 and 5 and y values 2 and 8. And let's mark in the point -3, 8, and then we'll mark in the point 5, 2, and then we can add the line. So first we can figure out what the run is, and that's equal to x2 minus x1. And choosing the biggest value of x to be x2, well that's 5, therefore x1 is -3. So remembering that minus and minus is plus, so the run has to be equal to 8. So to figure out the rise, well that's equal to y2 minus y1. So y2 has to be related to x2, so that's equal to 2, and y1 is equal to 8. So therefore our rise is equal to -6. So the gradient is equal to rise over run, which is equal to -6 over 8, which when I simplify it down is -3/4. Once again, notice that the point on the right was x2, y2. And by right, I mean it has the biggest x value. Okay, so I suggest you pause this video now, and those of you with the new book can do questions 1 and 2, and those of you with the old book can do questions 3. Okay, I'll see you in the next section. In this section, we're going to learn to find the equation of the line, the whole equation, given the y-intercept and a point. In this method, we use the y-intercept and another point to make the 2 points we use to find the gradient. Once we have the gradient, we only need to find c to complete the equation. Y equals mx plus c. So you only need to recall that the y-intercept is where x equals 0 and y equals c. So c is the y value in the y-intercept. Okay, let's use these facts for example 20, where we need to find the equation of this graph that I will draw now, which has a y-intercept of 1, and this other point 4, 13. So let's draw the line between them. And let's recall that the y-intercept has x value 0, so I can write it in coordinate form as 0, 1. And so let's figure out m, which equals a rise over run, which equals y2 minus y1 over x2 minus x1. Notice how I've used the colours just to make it really clear which x and which y relates to which point. That means that the rise is equal to 13 minus 1, and the run is equal to 4 minus 0. So if I mark in the run and then the rise, we can see that they're equal to 12 over 4, which I can mark in here as 12 and 4, and we can simplify 12 over 4 as equal to 3. Finally, we need to find c, but because c is always equal to the y value in the y-intercept, then c has to equal 1. Therefore, the equation is y equals 3x plus 1, with 3 being the gradient and 1 being c. Okay, time for you to try these problems. Pause the video now, and you should work on question 3 if you have the new book, and question 4 if you have the old book. And I'll see you in the next section. In this section, we're going to learn to find the equation of a line just given 2 points. Any 2 points. So first we use the 2 points, x1, y1 and x2, y2 to find the gradient, which is equal to rise over run. And as we've covered a few times already in this lesson, that's equal to y2 minus y1 divided by x2 minus x1. However, we still need to figure out c for the linear relation y equals mx plus c. By rearranging y equals mx plus c to y minus mx is equal to c, we can sub in any value of x and y with m to find c. Just remember that x and y must be a pair from a point on the line. Okay, let's put these facts to work in example 21. So here in example 21, we're asked to find the equation of the straight line shown. And let me make that appear with a magical click. Okay, here we see the equation has 2 points marked in. The first one is 3 and 11, the next one is 6 and 7. So to find m, first we need to find the rise, which is y2 minus y1, and then divide it by the run, which will be 6 minus 3. Note how I've used the colours to make it clear which point these numbers come from. So m is equal to 7 minus 11, which is minus 4, divided by 6 minus 3, which is 3, and we can't simplify that anymore. We know now that our m is equal to minus 4 on 3. However, we still need to figure out our c, but it'll be of the form y equals minus 4 on 3x plus c. So let's start by subbing in the point 311, where obviously the x value is 3 and the y value is 11. And to sub this back into our equation, we end up with 11 is equal to minus 4 on 3 times 3 plus c, which means 11 is equal to minus 4 plus c. So adding 4 to both sides, c must be equal to 15. Therefore our equation is y is equal to minus 4 on 3 times x plus 15. Now we can double check with the other point, so why don't we try and sub in the point 6, 7 and see if we get the same result. So with a y value of 7, that will equal our m value minus 4 on 3 times our x value 6 plus c. Then on the next line we'll have 7 is equal to minus 4 on 3 times 6 is minus 8 plus c. Let me neaten up that c, it looks a bit like a 6. So adding 8 to both sides, we have 15 is equal to c. So lucky for us, maths is not broken. And y equals minus 4 on 3x plus 15 is confirmed. Now I'd like to have a look at this particular equation in GeoGebra. So let's pop over there again and have a look at it. So our first point was 6, 7, and our other point was 3, 11. And let me zoom in a bit so I can find those exact values. So here our run is 3 and our rise is 4, but that's really negative 4 because we're going down. And what is our intercept? It is 15. Wow, all confirmed. So this minus 1.33 is really the same as minus 4 divided by 3. So that's exciting to know. Our method is confirmed in using both points and GeoGebra. So let's flip back to OneNote again. And now that we've confirmed our method in 3 different ways, students should be confident to go on and try this. So students, please do question 4 in the new book and question 5 in the old book. As always, I recommend you pause the video and do these now and apply the learning. Okay, I'll see you in the next section. Okay, in this section, we're going to talk about some special lines. So this is just a little bit extra, and those of you who paid attention in our last lesson will know these before I say them. But these are important facts and you need to write them down. You will be using them at different times. If we have a horizontal line, which I'll mark in the graph, with y-intercept equal to 0c, which I'll mark on the graph, then the equation is y equals c. And if we have a vertical line, which I'll mark on the graph, with an x-intercept equal to k0, which I'll mark on the line, then the equation is x is equal to k. So these are two facts you just need to write down and memorize. We've already learned how to figure out all the other graphs, but let's make one more section where I'll summarize all of those. It's important for this topic that we do a summary and take stock of your take-home skills and knowledge, because these skills and this knowledge is very important for a lot of things you're going to do in VCE. So to find the equation of a line, y equals mx plus c, from 2 points, such as this line, and denoting one point as x1, y1, and the other point as x2, y2, first you find the gradient, which is equal to rise over run, which is equal to y2 minus y1 for the rise, and x2 minus x1 for the run. Once you've got the gradient, then the second thing you do, you use m and x1, y1 to find c. Because if x1, y1 is on the line, then y1 is equal to m times x1 plus c, which is equivalent to saying y1 minus m times x1 is equal to c. Alternatively, you could just as easily say y2 minus m times x2 is equal to c, and that will give you the same answer. I've got a question that some of you might want to ponder. Can you use this 2-point method to figure out horizontal or vertical lines? If you can, why? If you can't, why not? Anyhow, that's an interesting thing to ponder, but please make sure you work hard on obtaining the skills before you try something like that. Alright, I'll see you in the next lesson.